Good afternoon, everyone. Uh, can someone please confirm whether you can hear me clearly without any issues? Can one of you please
Yes,
confirm?
yes,
Yeah,
we can.
great. So this is the third lecture actually. After having a discussion with Indura, so I thought I will be starting to work on the lecture with the concepts not relating to the UI, right? So UI part, most of the things I think are covered in the lab activity, and it is not that good to waste time on like introducing new different widgets to you guys on a lecture, because those widgets will be there for you to go and try out, right? So today we are going to dive into asynchronous programming. So in asynchronous programming, you have few things like in today's lecture, we'll be talking how to uh, how Flutter facilitates asynchronous programming, and at the same time, what is isolate, and then what is a event loop, and what is a future, how to use await and async. I think you already know about the await and async because you should have some kind of a knowledge in JavaScript, right? Then what are the streams, and finally how to deal with a stateful widget with asynchronous program, right? So in terms of like future builder and other things, right? So I don't have much slides today because I'll be using uh, the board to go through the concepts. So the first concept we need to talk about is why we actually need to talk about these things like, yes. So why do we need to talk about asynchronous programming? So what is the asynchronous programming? So in every one, so we know we have flow controls in programs, like we are calling them selection, uh, sequential, the normal flow, selection, and then iteration. So those are just to how to uh, control the flow in a program, right? But we all know, okay, if we have a thread like this, right? So we have one CPU. You may have several CPUs right now, but I'm talking about the basic idea, right? So with that one CPU, if we are giving out instructions one by one, like this, right? So we are sending instructions like this, right? Then the CPU will render like execute the instructions, and then something will happen. Maybe put some output to the screen, or do some calculation and put that output to the memory, or anything can happen, right? So, but in some places, we have a problem like if we do the same thing in the same thread, like same instruction flow, what can happen? So every time we go there, so we have the Flutter, whatever the UI that we have in here, right? So maybe we have a bar in here and some buttons in here, and you may have some cards in here like this. down, you can have a tap pen or something, right, in this app. Right, when you click on this card, what you will do is you will go to the storage and find out an image and some content, like in a text file. Let's see. In order to do this, let's hope it will take 2 seconds. Right. So the problem comes in this specific scenario. So I click on a button. So that instruction also gets added to here, right? So when I click on the button and the whole UI will stay unresponsive because I can't click on another button because the instructions are going running so that I can take the image and text from the storage, right? But we all know in 30 milliseconds, right? In 30 milliseconds, right? If we cannot do something, right? So if you cannot render something, a new one, the user will basically see, okay, there is some lagging. Okay, or there are some some unresponsiveness in that, right? If this case gets like really bad, and if it takes more than 5 seconds, right? More than 5 seconds, what will happen is the Android system or iOS system will show you a ANR message, ANR error message. So this will come from the OS. ANR message means application not responding. So they will be asking, okay, application is not responding. Do you want to close or do you want to wait? So will you use something like that if that happens all the time? No. So we need to do something out of the main thread, right? In main thread, the rendering and everything can go on. So if there are something, so we are calling if there are something that has CPU intensive task, or if there are something that is network incentive, or if there are something storage incentive, right? Storage incentive. So it will take more than the normal rendering time. So what do we have to do? Then we have to somehow find out a way of running things in the background, right? So we tell the application, okay, we have a problem like this. I have this CPU and intensive task that I want you to try out, but I don't want to like interrupt my main thread. So in Android system, we are calling this, that's either the main thread, right? Or we are calling that UI thread. So that will be the UI thread. So if we are taking more time to finish some execution in the UI thread, that simply means, okay, user will see that delay in the UI, right? So in Flutter, we are having something called the event loop, right? So we'll talk about it later, but that is the main reason for the requirement of having to run something in background, right? Or run something in parallel, right? So we all know we are running things in parallel in normal machines so that 2 or 3 apps can run in the users will feel like okay, these things are running parallel, right? So what we are doing is time sharing, right? So that is the upper idea. But here what we are going to do is In the same application, the things that will take more time to finish, we are putting them into a background thread, and all the other things we are putting them uh, into the normal main UI. Right? I think that is key. Then what we have to call is okay. Then we have to talk about in Flutter. How do we say, okay, run this in background? In Flutter, we need to have something to say, run this in background. So how do we do that? So actually, now what we are trying to do is our main thread is going like this. In here, user taps on a button. By that button, we need to run some network tasks. So what we are doing is we let this main thread to go on its own way with its instructions. So we are starting a new thread and we are giving our instructions in here. Right? So we are calling this a main thread. I think this is something you already know, but I need to cover that so we can then talk about the specifics related to Flutter. So we are calling this child thread. So this is the normal way you will be doing something in Java, PHP, or Node. In JavaScript is totally asynchronous language, right? So if there is a network call, JavaScript don't even allow you to try that in a synchronized manner, right? So that is why some things we are doing on our machines. So even though we are doing trying to show something, right? If I'm trying to show something synchronous and having a problem with that, I cannot show that in the web mode, right? Because in the web mode, that will be compiled into the JavaScript. So it is a language that only allows you to write asynchronous code. So let's go to our code and see the problem at hand, right? So this is our code. So let me run that again. So I'm using the iPhone version because I don't know for some reason for last few weeks the Android one gives me some delay, right? So I don't know whether that is a problem with the new API or something. And unfortunately, I didn't have time to check on that. So I'll be using the iOS version for this. So in iOS version, this is what we did last week, like creating something so we can increase the number that is shown there, right? So let's try to do something like what? Adding something there, right? So that before doing that task, the whole thread will stop for few seconds, right? So so in this, so we have the stateful widget. In my state, I have this button pressed. So in there, I'm going to set the state. So what I'm going to do is I'm going to use Flutter IO sleep function, right? In there, I am giving out the duration in seconds. Right, so let's take 5 seconds. Right, so you saw that it before restarting this, let's see this again. So you can see, okay, it is running all right. So now we are going to do is we are going to reload and see. Okay, now you can see when I click on the button, what will happen? It will wait for 5 seconds, and you can see I can't even click on the button after that, after I click it for one time, right? So the whole screen gets not responsive. See, so but unlike Android, so you can see, even though I cannot click on the button at that time, what Flutter do is Flutter registers that event. Okay, the user tried to click on that, right? So even the Flutter does not respond to it, right? That event will be registered. So you can see, okay, I click on this and I'm again clicking on this, right? So but it is unresponsive. Then you can see in 5 minutes, you can see, okay, 4 and 5 at the same time, right? But because of this, the event, the whole screen gets unresponsive. So that is the issue. So what do we need to do now? What we need to do is, we need to basically, so let's think that sleep task is a task that we want to do, like 5-second thing that will happen in the network. Right? Let's see that like that, right? Then what we need to do is that 5-second thing we are going to put in the child thread. So when we get the output in here, right? So then we are going to go back here and do some changes, right? That is the normal way Android handles it, Java handles it, and every other language handles it. But in Flutter, we have the same concept like running 2 or 3 threads. But we don't have something called, okay, this is the main thread, this is the child thread. So main thread have something to do with the child thread, right? So we don't have that feature in Flutter. In Flutter, what we have is something called a isolate, right? So we are, in Flutter, we are calling that a isolate. In isolate, what we do is, we are creating, for one thread, we are creating a separate instructions, and the most important thing, right? So the instructions separation is there for all the other languages as well, not only for the Dart, right? But in Dart, we have a separate what? Memory space as well. That basically means, let's see, in the main UI, you have a some kind of a int called x. So that is 10, right? So for that same variable, if that is available for the child thread can go there and change this 10 into something else. But in Flutter, we cannot do that, right? So even if there is a variable in the child thread we want to change, we cannot do that, because each thread or each isolate will be isolated from 2 separate things. One is the instructions, the other one is the memory, right? Then you get the issue of having, like, you cannot have share, you cannot share the memory, right? So while the threads are running, you cannot actually go to other threads memory and do something, or even you cannot have a shareable memory space where the both threads will write that into, right? So I think you have some kind of a knowledge about threads, and in threads, what we are trying to do is, we are calling something concurrency control, right? Concurrency control means, in threads, we are trying to do run several threads, and at the same time, when they are accessing these the same memory locations, then we have to somehow control that. That's why these locks and semaphores and everything comes into play. But in Dart, we don't have that problem. But the problem here is, okay, two isolates cannot have shareable memory, right? So that is a uh, in mobile computing or other places. Okay, we are calling that it's this bit strange, and for some specific applications, it is really hard, right? So because in most of the languages, we are really used to have shareable memory and access it via two uh, threads, but in Flutter or Dart, we cannot do that. But in Flutter, what we can do is we can pass messages from one thread to another, right? So we can pass messages. So by passing messages, okay, we can achieve that problem, but that is not that easy, like we do in having a shareable memory. But what I see in my point of view, I think that is really thread safe. Why it is thread safe? Because we don't share the memory, no? So we don't have to actually care about the concurrency control or anything, because I'm not going to access the same set of resources at the same time, right? So that feature is there. That is the first thing. So there were a few words in there. So isolate is what? Isolate is a container that a new Flutter or new Dart thread starts working, right? So in that isolate, other threads don't have anything to do with one isolate, right? So even the thread that created the new isolate don't have power over that isolate. So you cannot, since you have created that from the main thread, you cannot go there and see what is happening inside that isolate, right? So because of that, we don't need the concurrency control. But the problem here is, when we are communicating with each thread, we need to have some kind of a mechanism for that. Okay. So before moving into anything else, did you get the idea why we need asynchronous programming in a mobile application development, right? In other applications, we don't really talk about asynchronous programming. We talk about it, but not that importance is given for the asynchronous programming when we are doing web programming or any other desktop level application program. But in mobile programming, we are really talking about it. One reason is, if a task is CPU intensive, yes, it's the mobiles does not have that kind of a power to like instantly do that. And mobile means it is mobile, so there are network issues and many other things. Because of that, we need to somehow think about, if the uh, download get delayed, what should we show, right? So there are things like that. So before moving into futures or anything, are we clear on why we need asynchronous programming? What is isolate, and the difference between the normal Java or PHP or any other asynchronous model with the Dart asynchronous model. Right? If you can clear, what you can do is, I want to get your feedback, not like I'm talking to some computer. So if you get it, you can give a thumbs up, or you can ask any questions related to this, so I can clear them up before moving into the deeper concepts. Okay, so no thumbs up means you didn't get it, and at the same time you don't have questions. Is that what you are saying? Okay, one got the idea. What about others? Are you typing something, or do you don't have any idea whether you understood it or not? Is that so?
Excuse me, sir. Actually, the explanation didn't clear for me because I got the idea, the isolation part, since we don't share the memory and memory space. So then there will be no. It will be pet safe. I get it. But since the isolation will doing isolation, it will also at cost, right? And we actually need some shared memory actually when doing programming things.
Yeah, exactly. So that is why everybody is complaining about this specific asynchronous handling in Flutter, right? So that would be really convenient if there is shared memory. But I said as a feature, what we are having is it is a bit hard to handle the asynchronous programming with no shared memory, right? But in other hand, it will be thread set. So there are actually conversations going on even right now, okay, whether to include that in the Dart or not, right? So they are considering the both things. Maybe in a future update, they will give back the shared memory feature. But for now, what we have in that is the isolate. In isolate, we cannot really come up with a shared memory for two different threads.
Okay, sir. Thank you, sir.
Okay, then so that is about the isolate and the user thread, right? So before going on to the futures, so future is actually, yeah, let's talk about the future first, right? So future is actually the main mechanism given to us. Okay, before that, let me just let you know for which tasks we are using this, right? So for what tasks? So first one is if you have IO, right, input or output task that is required to be action, whether it is fast or not, we try to go for a asynchronous one, right? And if our UI needs to be repainted, right? If you want to add something to the UI or update something in the UI, so that also you can do in asynchronous task. So after all the updates are done, it will appear on the UI, right? Or if you have something like large number of CPU intensive things to do, right? So then again, we are going to do that in a asynchronous mode. And finally, in some places, right, even if they are not that CPU intensive or IO related, if we have to like two tasks which we have a clear boundary, right? So we are saying, okay, this one is totally independent from the other one, right? So in rare places like that, if you want to get them independent from one to another, then we are still gonna do that thing, right? So that is the idea, right? So your examples, you can take it as HTTP request or getting some data from an API or loading a file or saving a file, right? Or saving something into the database. So you can do that, right? So you know what is an isolate now. Then let's talk about the event loop, right? So event loop again gives you some kind of a idea on how these asynchronous, finally whatever we do in asynchronous, the rendering should happen in one main thread, no? So that thread we are calling the event loop. So in every so I don't know the new value, but every like 40 milliseconds the event loop will check whether there are any changes to the UI, right? So it will check whether there are any changes to the UI. So you get some idea from that. If it is a stateless one, stateless UI part, then you know, okay, whatever happens in the background in a stateless widget, right? There won't be any changes. So event loop don't have to go there and check. That's why we are saying whatever you have to do in a dynamic manner, at that part, add only that part as a stateful widget. Because let's see, this is our application. Then we have all these things, action bar and cards and everything. These are stateless, right? So we have something in here, right? Something to show notifications or something. This part only we are taking it as a stateful, right? So all these things are stateless. So the idea is when event loop runs and when it is trying to re-render the whole thing, right? It doesn't have to even check for all these parts of the code because we know, okay, these are stateless. So that means those are immutable. Immutable means those things are not going to change, right? So it only needs to re-render this part of the rendering tree, right? So it is very clear, and because of that, it is really efficient, right? That is the main reason we are saying, okay, always go for the stateless only for the widgets or only for the containers or only for the part you need it to be dynamic, go for the stateful, right? So I'm using this time to explain that thing as well, right? So in event loop, what will happen? So we have event loop, and finally, let's take, okay, this is where it executes those events, right? So in Flutter event loop, or basically Dart event loop, what we are doing is we are not like in the event loop, we are registering each and every event that is happening. even though whether there are some more instructions going on in here, right? Let's say this is a user tab, right? So that is still executing in the loop. Then again, user do some multi-finger gesture. So there are some tasks. So even though this is unresponsive, when user do this, it will register it and add it to the event loop. That means not like other things. In here in Flutter, if you do something, right? So that will be registered and will be added to the loop. That means it ensures that event will get its response, even without like independent of whether the UI or the main thread was responsive or unresponsive in that time, right? So user will see that is unresponsive, but when you do some task, it will also will be added to the event loop, right? So that's the thing. So when user tap and when executing, okay, I need to asynchronously run something. So I'm going for async task, not async task. In Flutter, we are calling that a future. So let's talk about it. So we are going for that. So in a future, we get the output. So that will be a callback function, right? So when that callback function runs, it will again be get it added back to here. So when you have the data, so callback function will add to the event loop, right? So then it will come here and then the Flutter will execute that. So that is what we are saying. So we have the event loop, right? And event loop is what makes asynchronous programming possible in Dart or Flutter, right? That means, so otherwise, if we don't have a shared memory, or finally, if we are going back to the data to the main loop, right? So we think it is not that possible to do several things. But in event loop just registers things when something happens from any other thread rather than the main thread. It will register that, and finally it will execute and it will be added to the UI, right? So in mobile computing, we are always focusing on the UI. So for that, we have reasons, because if there is some delay or anything, if it is draining power, if it is using your whole bandwidth, then what will happen? Users won't use your application, right? So that is why we are focusing more onto the user's side when we are dealing with mobile applications, right? So this is what we are calling the event loop, right? So it is just you have to get the idea of how this event loop works, right? Then the important thing is the future, right? So that means when we are doing asynchronous task, right? When we are handling asynchronous task, right? So let's say our function is asynchronous. That means from our function, what we are returning is a future, right? So from our function, what we are returning is a future, right? So when we are returning a future, okay, we know, okay, this is what we want to do. Or there can be things like future value or future delay. There are things can happen, but the idea is, so when we are creating some function, let's say we have a function named something like what? So let's say we have something like a number creator or something, which we have in there. So that number creator should always return what? A future. So it should return a future, whatever the function is, it will return a future, and it will be something called number creator or something. So we know, okay, when something is returning a future, we know that task, right? So is actually an asynchronous task. So what you can do is we are calling, let's try to create a future, right? Then print something after some delay, right? Then we can check out whether that non-responsiveness or anything was there or not, right? So right. In here, so where do we need to have a future? In here we need to have a future, right? So what we can do is, and another thing, in future we have several states. So one we can say one is uncompleted. So for another thing we can say it is completed with the value, right? Or then completed with the error, right? So that is the states of future, right? So okay, so let's create this one. So let's create a future, so that will print something, right? Instead of doing something to the UI, so it will print something. What we can check out is, so when we are clicking on this button, right? So we are setting the state now, so it will increase the data hold. So we can have like a future, right? That will print something after it is done, right? So let's try that out. So it should be returning a future, right? So let's say async test function. So we have async test function. So we are returning a future, right? In that function, we should return a future. So I'll be returning a delayed future delayed, because I want to delay whatever happening there for 5 minutes, right? So let's see. So I'll be going for a return. I'm returning a future future delay, right? for the duration, I can give again 5 seconds. Right. Now what we can do is, so we have it there. So we have given the duration, then we need to give it the function, give it a function, right? Give it something to do. So I'm going to create inline function for that, right? So what it will do is print something, just future done. Right. So let's try to format. So let's go again and see what we have in here. So we are creating a function called async test function that is returning a future. So I'm going to return a future name that is delayed, which means it will do whatever we are giving here after 5 seconds. So it will have a 5-second delay to do that, right? So we are giving out a function to perform there. Then we are saying, okay, please wait 5 seconds before doing that, right? Now, what I want to do here is I'm just calling async test function, right? I don't have to give anything there. Now let's see, right? So it will instantly get updated, but okay, where is the console? Okay, let's see again. So it is giving me future done, right? When I click again, so it will get 5. After 5 seconds, we will be getting the console output, right? You can see. So I can actually do this for several, and you can see after waiting 5 seconds, each future will run, right? So that's the idea, right? So it is not that hard to create something to run asynchronously. What we have to do is just give something that will return a future, right? So then at the same time, right? So this is our future. So sometimes you will need to wait for some, right? So you will need to wait for something to happen, right? So how to do that part? Right. So we are still not getting some data. So we are only getting a future, right? So the future will do something, right? So that's the only thing, right? So in a future, when we are creating a future, it will run some function, right? So some functions like HTTP GET or something, it will have a built-in future, right? Most of the network calls in Flutter, it will already have a built-in future. So you don't have to worry. You can just take var future. right? And then you can cache that, right? http.get. You are given the URL, right? So you will get the future. So in future, what we can do is, then we can, sorry, it's simple future, right? Then what we can do is take that future, and then we can call then. And whatever the output we get from that future, right? If that future is returning something, right? Returning something, we can get that output, right? So because we are again calling a function, so if that function calling, we can get that value, right? Then what we can do is we can say, okay, then value, right? So we can cache that and do some statements in here, hit something or add something or do something, right? So finally you have to what you have to do is you have to close this then, right? That means, so the one we did right now, it doesn't have a value, right? So we are not getting any value from there, but if there are some value, so we can get that, right? For an instance, let's try to get something from API and try to print that in a console log. Yeah, so get a browser. As I remember, there was something to do with this. So let's get something from the JSON placeholder. Right. JSON placeholder. Yeah, I remember something like typecode .com. So it is a fake REST. So yeah, let's go to this one. So this is typecode.com and users. So we'll be getting this JSON when we call a HTTP GET, right? So let's copy that thing, right? And we can go back to the code. In this code, instead of saying, okay, run this, right? So we are not returning anything in here. So we can just say return http.get. Okay, in order to do that, I need to import data async. Right. So in here, okay. So for the easiness, let's import the http.dart as http, right? Right. import package async dot no HTTP. So in order to do this, you have to do something, right? Go to this pub spec, right? And you have to add HTTP to that, right? As a dependency. Then you can work on this, right? So you have the HTTP, then we can just call the HTTP dot, okay, sorry, here HTTP dot as HTTP. So it is easy for us to do, right? Then in here you can just say HTTP dot get, right? You have to give the URL. So URL is this, right? So right. So you cannot really add the URL as a string. You have to use the URL parser. Right. So what should happen? So when we call the async test function, it would return a future that is already built in this HTTP get HTTP method, right? You can see it will give you HTTP response, right? So the type will be response, right? So now what we have to do is in here, right, when we are running this, we are calling that var future. Should be simple future. And then what we have to do is, so we have the future, right? So we know from that future, it will return a response. So what I'm going to do is I'm going to write future dot then write value, and if we get something as a value, so we know it is a response, right? So first we need to know the status code to do something, right? So I'm not going to do that. I'm going to add there a print. So in that print, I would print the value dot, if I remember, yeah, body. Yes. So we have a function in here. So what is the function? We are calling the future. Then when that future is completed, we are saying, okay, whatever you get as a value, please print that into the console. Now we can try this out. Right? So we instantly get the thing because it doesn't have a delay. But you can see by doing that, you can actually get the HTTP response, right? So nothing much to do. in Flutter if you want to get something, right? So, but if you are getting something, you need to use these tasks and they will be asynchronous. So you need to handle that in a callback function. Not like you can get this and put this somewhere, right? But what you can do is, after getting this value, right, instead of printing this, what you can do is either you can set the state. Let's write that part as well. So you can run a set state. Let's make this a function scope. So inside that you can call the set state. Right. So in this can try out to do this data holder plus equal not is equal to value dot status code. Right. So let's write out. Right. So you'll get the value in here. So let me keep more clear. Let's add a print. Yeah, let's try to value dot body, and the same time we can try that. Right. So now we should get both of the things. Okay, is there something? Sure. Sorry. So we are in a future then call. Inside that, Okay, so it is basically only letting me try only one statement. Yeah, so I tried to put both in here. So if you want to add both in here, what you will have to do is you will have to make it another function and use it there, right? So now you can see, okay, after some time, it will become 200, right? Which means the JSON code. Or since this my data holder is int, we cannot do anything else. So if we get back to our concepts, so that means in a future, is an object, right? So this object is like a promise in JavaScript. If you know promises, then you won't have any problems with the future. The same syntax, only the name is the only difference is the name, right? Same way you will be using it. So it is the same JavaScript code, right? So future is basically when I'm teaching this, I like the word promise better than a future, right? So promise means, okay, I am promising you I'll be getting that data and I'll have a callback function to process that data. So the same thing will happen from a future. So if you get a future and inside a future, if you add a function, so that function can be one line of a code, or you can actually create a function that will return a future, right? So anything you can do. Future means I'm promising you results after it doing something, right? After doing something, I am promising you some results, right? So that's the idea. So initially, what will happen is I'm keeping track of, so when I call the HTTP GET, so let's talk about the event loop again. So I'm calling that, right? Then I'm caching a future, right? So this returns me a future, right? By this value in the main thread, what I can do is, okay, you have a future. So future I can link into, okay, future. When you get the value, right? Then means that, right? If you get a value, you can do something like this, or if you get an error, you can do something like this, right? So we can write that same as a promise. So what will happen is, so this function will run in the background, right? Basically, background. So in the event loop, we don't have it because it will run on a different isolate. But after it finishes, it will call this, whatever the statements that we are giving in here, right? After it finishes with the value that is getting returned from that function, these callback functions will trigger. So that means when that asynchronous function returns, what it will do is it will add a event trigger in the event loop, right? So after finishing that, then when that trigger gets a chance, it will go to the future and find out whether there are any callback functions to complete, right? If there are any callback functions, it will complete the work and fully, I think task will get completed. So in the event loop, when we are saying, okay, go there and check whether there are any callback functions, if the callback functions are not there, basically we will be finishing that task. right? So that's the idea. Then how to use this? And in Flutter, you can do really nice things with this, because in Flutter we have something called future builder. Right? So in future builder, what we are doing is, okay, for the future builder, we are giving out, so let's say we are giving out this HTTP response for the future builder. So then that HTTP response or whatever, until that finishes, we can return something, right? So in future builder, basically it returns a widget. Okay. So until that task finish, we can return what? We can return something like a loader or something there, right? So after we get the value, we can show that value. So it is like, you don't have to, like this ICTA do, you don't have to like add a sleep to show that loader there, right? So in their full lab, what they have done is they have added a nice loader like this that will repeat. So in order to show this, that guy have, what that guy have done is basically add a sleep there, right? So for 2 seconds or 1 second, you will be slowing that loader, whether there are any loading to do or not, right? So that is Sri Lanka. So after that, what they are doing is, after that they are going to send the request and get the data back. But we are not going to do something like that. What we are going to do is, we are going to have two things. So either you can have, until it is loading, you are showing this can be an item, right? Then after data comes, you can show like something like this. So this can be a text, right? From a future builder, so that's the point. So you can return any component you like. So before you can send an icon or show an image, when you get something, you can show a table or you can show a card, right? So you get the flexibility, right? So that is the last part we have to cover. Let's try that as a practice. How we are doing that. Right. So I'm thinking to where I'm heading this, right? So let's say for this icon, I'm adding the future builder. Right. So I need to say what is the future in there, right? Whether there is a builder or not. Right. So let me add that there first. So even I'm sometimes in Dart code, it is really hard to keep track of the number of parentheses that is there. So then inside that, we need to come up with the future, right? So for future, I'll be giving that exact thing, right? this HTTP get our user string. So that is the future, right? So that part is done. Then we have to give what is the builder. So right. So in that builder, we can say what we are getting from the future. So one is the current configuration. So I am adding it as a context. Then for the next part, I can add it as the response I get from the future, right? So we are creating the right. So for the builder, I'm taking the context and the response. Then I'm saying if my response have data, that means I get something from the field, I can say, okay, add some text in here. No, return right. Then I'm adding response dot for now. We cannot show the whole thing, so let's just add some normal string. So otherwise it won't be visible. So I got data, right? So you can return anything in there, right? Then if that is not, we can say, okay, always return what? We have something called circular progress indicator, right? So we can go for that. So I'm saying, okay, if that is not circular progress, show a circular progress indicator, right? So since we get data really fast, I won't think so in order to see that, see quickly we get I got data, right? So you can see the progress indicator is also there. Let me check whether we can. So what we can do is actually let's do it like this. Instead of calling this directly, let's add some delay into that, and then let's call our function that is there. So we are returning this now. So instead of returning this, let me add yeah, let's add a future delayed in here. duration will give. Let's add 5 seconds. Then for this, I will be needing a function, right? So for that function, I'll be running await and that HTTP get. So I'll be just right. So let's try to run this now. So now you can see this is waiting for some time, then it will call, okay, I got data, right? So that is a really cool feature I have seen in Flutter, because then we don't have to worry about, okay, go there and change in the UI, right? If you are going for a new page, what you can do is add a progress indicator in the middle and create a table or something when there's data, right? So otherwise, if you have some experience with Android or any other language, so you know how hard it is. So we have to get the data and we have to go back to the UI tree, and from there we have to change that into a tree or something, right? The whole UI thread widget tree we have to change. But with this feature, it is really not necessary, because we can really easily do that, right? So if you want to populate a table, right? Let's see, you have something like you have to get the vendors names and everything, or set up users name and their status and everything. So you can actually generate the whole thing inside this future builder, like add the table, and inside that table for a row you can add buttons that will do performs a specific tasks, right? From the idea or your experience from UI, you can actually try that with the future builder, right? So you don't have to like sleep it like I did, right? So you can directly give that as a future. So if that takes time, it will show the progress indicator, otherwise you get the data. So that's the idea. So the correct code would be just, without putting that as a future and adding it as here, right? What you can do is, you know, how many, do the same thing like this, right? So directly what you get is, I got data after like 1 second of progress indicator. So we know every progress indicator is in the application is performing it correctly, right? If for some computation, if it is taking some task time, what you can do is you can put that thing into a asynchronous function and perform that while you can show something else, right? That is how we are linking the future builder into a widget tree, right? So you should get the idea. And another thing, I'm not giving you the answer. Try and, so here I'm adding this future builder into what? Into a stateful widget. So what do you think? Will a future builder work inside a stateless widget? What do you think? will it work inside a stateless widget? So you can actually try it out. Let's go into Flutter docs. Right. So see the inheritance. Future builder is a stateful widget. So because future build itself is a stateful widget, you don't have to like create a state for that widget, so that you can just plug a future builder inside into your own stateless or stateful widget, right? It doesn't matter whether you are adding the future builder into a stateless widget or a stateful widget, as long as the future builder itself is a stateful widget. So it have its own state. So it will do its work, right? So that's the idea. So in a fully stateless widget, what you can do is you can easily plug in a stateful widget. So only that stateful widget will be dynamic. All the other things will be immutable, right? So you don't have to re-render everything. You are only keeping track of that stateful widget, and you will be re-rendering the whole thing, but you are not checking for changes in other widgets, right? So your rendering tree would be the same one, right? Because of that, when you are doing that with Flutter, it is really fast. Even though you have a dynamic DOM and everything in React Native, right? So it is not that fast. So that's the thing, right? So if you work with React Native, Flutter, and Android Native, so you will understand, right? Basically, Android Native is the fastest. So you cannot change that. The native in your when you are writing in native language, it will perform better. It will have all the you will have all the features. So you can open camera app and everything you can do, and even the sensors you can use easily, right? But in Flutter, it is a bit harder than when you are doing it with the native language, Kotlin or Java. But Flutter is pretty fast and efficient than React Native. But React Native have its own features, where sometimes when you are taking the decision, sometimes you have to consider about the other things as well, right? So that's about the idea that we have with the future build. Then finally, we have something called streams, right? I'm not going to do any like coding with respect to that, because in order to do coding, so please try to do that in the lab, right? So I've seen Idora's work, so he's actually going through everything. So I hope that you are getting a good lab session, right? So he's going through everything. So what you can do is you should try to follow him up and do that, right? So next week you have the mid-semester break. So next Wednesday we won't have any lectures, and week after next I will be taking the practical session, and Indora will do the practical in the lecture slot, right? We'll be changing the lecture slot and the practical slot. A week after next, if this QR works and if you have work, let's try to do a practical session on UCSC in the labs. So we have already allocated 3 labs for your practical, right? The third year lab, then MSc lab 1 and 2. Then there we can actually answer if you have any questions, because right now I don't really see whether you are following the practical and you are doing any work. That is the main disadvantage of doing this on an online environment, right? So with respect to the mini project, right? So we have already finalized after thinking about many scenarios. So for mini project, we will be giving you time, like we will be giving even 1 week after the exam, right? So the deadline is, that is a like fixed deadline. I'm not going to change it for any reason. So if you can work it out before the exams, do it, right? So it will be only a 1 week. So I cannot give you a fixed date because I don't know the exam date. So you will have 1 week after the exam to finish the mini project. Then that exact week, you will be having to face a viva, right? So since you are in intern, we can give you some options, but there will be a viva for sure, right? So keep that in mind as well. So since some of you asked what is the deadline, so I'm not going to push you to do it before the exam. So do the exam. So get in the question paper, you'll get some more understanding about the Flutter and how this works. Then after that, you will have 1 more week to finish the mini project. Right. So that's the thing. Yeah, no more announcements to do. So I just want to get some feedback about the practical session, right? So how it is going. Like whether it is good, do you have any suggestions that we can change? And even in the lecture as well, not only the practical session. So if it is good, you can at least say it is good. So I know it is good. So otherwise it is like you are keeping the laptop open and you have won something. Okay, only one response for now. If you have some suggestions, yeah, we'll like to change how we are doing things. Okay. So nobody's here. You don't have any opinion or feedback for lecture or practical. So I'm not going to do any changes because you didn't say anything. So we are going to continue like this. Okay. So that means finally what we are trying to do here is, so this year we changed the way we have done it for from last year. That is why I have the flexibility of changing the topics that I'll be talking in the lectures. And I'm getting the full help from the practical session because this is a practical subject, right? So what I want you to do is try everything that is there, complete the lab sheet and everything, right? So you will be better, and since you are going for your internships, right? So it will be really helpful if you master a thing like Flutter, because most of the in industrial places will be using that for mobile application development, right? But the reason that I cannot do the practical aspect in all of the lectures and not having a lab session, like, I can do the thing. No, you will be thinking, okay, you can do the practical aspect, but the thing here is when someone is taking, like, in the whole world, when we are saying about mobile application development course, it is not only teaching you how to do some coding in some framework, right? So there are many other aspects related to that, like why we do specific things that way, not in the web applications, right? How to select the correct framework, what are the UX principles that we have to follow, why that UX and prototyping is so important when it comes to mobile application development. There are many things like that you need to know, because those are the main concepts. So when you are saying, okay, I learned about mobile application development, everybody will assume that you know the reasons. So you should be able to say why we are handling some things in our own API server instead of doing that in normal your own mobile phone, right? So you should be able to justify things. Okay, if everything is going on correctly, I'm finished the lecture now. So seems like you are not asking much questions, and but you should have questions when you are attending the practical, right? So in lecture, I don't mind because some of you may be going through the lectures when it is near to the examinations. So I get that, and I don't have a problem with that. But you guys should make sure that you are following the practical correctly. So if you miss certain things, like for the mini project, you will have to use Flutter authentication for the authentication to give social logins and everything. Then you have to save data in the Flutter Firestore in Firebase. There are some requirements like this. So you will be, it will be really hard if you don't practice this in this level, because when it goes to the later weeks, you will have many assignments to try out, right? So this week, this Friday, we will be publishing the assessment, and you will have to submit that a week after the last day of your paper, third year first semester examination paper. Right? You will get 7 more days after that, right? So 7 more days. I'm not saying about your third year projects, right? So I can't do anything. If third year presentations are going on, I'm not calculating that for that 7 days. From your last paper, you will have 7 days time to submit this, right? And I want one individual project from each, because this is a really easy framework that you have to try. We are not asking for many features. So those features you have to create one for yourself. Right, that's all. At least from the assessment, do you have any questions before finishing the session? Yes, Sanjula, you can create a mobile game, but using Flutter. Right, so we will be giving you the basic things that should be there, right? So there should be API calls, and there should be you should use Flutter Firebase authentication and Firestore. If you can do the same thing while creating a mobile game, I won't mind. So I'm not trying to give you a scenario. I am just giving you the basic features that should be there in your application. Okay. Seems like no other questions. Okay, then let's end the session. See you guys on not next Wednesday, a week after next Thursday morning, Tuesday morning. Right. Goodbye.